Welcome to Chapter 7 and our friends radicals. We have a lot of things that we're going to work with radicals over the next 7 sections in our textbook. So let's get started here. I'll try to keep this video under 10 minutes if I can, but I'm going to go through things kind of fast and furious. So anytime you need to pause a video, be sure to stop it and pause it so you can take a look at what I'm doing. My target for you in the first lesson is that we are going to review finding the square root of a number. Then you should be able to find the square root of a monomial. And lastly, we're going to do some work with cube roots of numbers and cube roots of monomials. A couple of things before we get started. I'd like for you to put on your paper, I would like for you to write this down, please. Write down the perfect squares. All right, we're going to put down the title perfect squares, and we've done this before, but let's just write it down again. Why is this so big? I don't need it that big. All right, so perfect squares. Why don't you write this down? Let's write down the first 10 perfect squares. In other words, 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, and 8 times 8 is 64, and 9 times 9 is 81, and 10 times 10 is 100. The next thing I want us to put down are what we call the perfect cubes. And we won't put as many of those down because they get quite large quite fast. Obviously, the first one, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. And 7 times 7 times 7, oops, I got to grab my calculator. I don't want to make sure I have the correct answer for you in that one. 7 to the third power is 343. And lastly, let's do 8 to the third power. That is going to be 8 times 8 times 8. That's 512. So we'll stop there with 8 perfect cubes. Why don't you get those listed on your paper? It'll be good to have these listed for you. Keep this on a separate sheet. Don't put it where you have it with your examples. Keep this on a sheet that you will keep in your notebook. So during chapter 7, you can refer back to these. All right, to start with, let's take a look at what is the difference between the square root of 36 and the negative square root of 36. Well, the difference being their answers. In our answers here, the square root of 36, the answer is positive 6. And then I have a negative sign out in front of the square root symbol, that means I want the negative square root. So it will be negative 6. So I have a positive square root and a negative square root both that you'll be working with. Negative square root is when I ask for the negative sign on the outside of a regular number out here. If it's not there, I'm after the positive square root. Second, how do we find something like the square root of 8 or x to the 8th power? Square root of x to the 8th power. What I have to ask myself is what was multiplied by itself to give me x to the 8th? What number can I add to itself to get 8? Think for a second. When I look at that, the answer to that happens to be 4, because 4 plus 4 is 8. So the square root of this, the square root of x to the 8th power, that equals x to the 4th. X to the 4th. Because I can do x to the 4th times x to the 4th, and I get x to the 8th. Make sure to take a moment, write that down, take a look at it. All right, and I'll be showing you more examples here that have variables in them. So here is, what is 36 times x to the 6th? What is the square root of 36x to the 6th? When you have a number inside the square root symbol and a expression x to the 6th power, this is a monomial. So I will do the square root of 36 separately and the square root of x to the 6th separately to find my answer. So what do I have here? Equals square root of 36, I know that to be 6. The square root of x to the 6th power. All right, what number added to itself gives me 6? That's correct, it's 3. So then I say 6 times x cubed. And just to show you, let me write that down here and I'll put it in a different color. If I have 6x cubed times 6x cubed, do my numbers. 6 times 6, 36. X cubed times x cubed. Add your exponents. 3 plus 3 is 6. 36x to the 6 power, and notice now I have the same answer as what I had back underneath my square root symbol. Or actually, you'll hear me to refer to this as the radical sign. I have a radical sign here. All right. If you have any questions at this point, I'd stop the video, bring it over to me, and I will be happy to answer things for you. What do we do with the square root of negative 25? The negative is not on the inside, on the outside of the square root symbol, it's on the inside. Well, folks, we say this. If I get a negative inside of square root, we say this. It is not a real number. That's all I do. Later on, I'm going to show you when we get towards the end of the chapter 7, we get about chapter 7, section 7, then we'll deal with, and I'll show you how to deal with a negative sign on the inside. But it is not a real number. So right now, we're just going to put, if I am not a real number, if I get a negative on the inside of the square root symbol. Negative on the outside is different. Negative on the inside, that's not a real number. Next, I want you to take your calculator and I want you to find a pattern. I want you to take the calculator and find the square root of 0.49. Then find the square root of 0.049. Then find the square root of 0.0049 and then square root of 0.00049. All right, there will be a pattern. There's a relationship, letter A and letter C. You'll see something in their answers that is the same. And then you have letters B and D have something in their relationship that is the same. See if you can figure out how are A and C related and how are B and D related. There's things in common with your answer, and it's because of the number underneath the square root symbol. So see if you can figure out what that actual pattern is. I won't tell you. Why don't you bring it over to me and I will show you and explain. And you can try to explain it to me. If you're correct, I'll let you know. If you're not, we'll discuss that together. All right, we're reaching 7 minutes, so I want to keep moving along. Time to review the calculator functions. Notice these handy dandy little pictures I have. One on the left is the calculator that most of you have, and the one on the right is the calculator that I have in the classroom. All right, if you're asked to find a cube root, because that's where I'm going, you're going to see something that looks like this, a 3 on the outside of that symbol, the radical symbol. When you see a 3 out here, that means we want a cubed root. I want to know what number times itself 3 times equals what I see under the radical sign. Well, on the calculator, to do a cubed root, on this calculator, the TI-30X2S, which many of you have, the cube root function is right above the caret key. What you'll see is it's right there where I'm putting the green arrow. It looks like this. There's a little X, and then there's a radical sign. It's going to be right there. So you will need to press that key. What you have to do when you press it on your calculator, you're going to type, since I want a cube root, I would type a 3, and then I'm going to type second, the light blue function. And the reason I have to do that is written in the light blue color above the key, so I have to type that, I have to press that second function, and then I will press that X to the radical symbol, and then type my number. If it happens to be like 27, then I type the number 27, and then I hit equals. If I'm using the calculator that you borrowed from me from class over up on the wall, then it is very similar. It has the X, the cube root key, or actually no matter what power you have, is above the arrow key on this one also. And it is still typed in the same way. I would still type in what root I'm after. In this case, we'll be after cube root. So you'll type a 3, and then you're going to push the second key. So you're going to want that second function key. And then you're going to want to press this key, the X radical key, and then you're going to type in the number that you're after, and it will tell you the cube root. So if I'm after the cube root of 64. All right, so let's take a look down here. What is the cube root of 8? What is the cube root of 8? If you take your calculator, type in the 3, type in second, type in the radical function, and then type 8. And when you do that, you're going to see that you get this answer, 2. And we listed a little while ago, we listed the perfect cubes, and if you'll see, 2 is on there. I'm sorry, 8 is on there, and it is the second number in the list. Why is it the second number in the list? Because the cube root of 8 is 2. 2 times 2, that's 4, times 2, and that's 8. So what do I do when I have a negative? A little while ago we said can't do that. There's a difference here. This is an odd number. I am after an odd amount of factors. Up above, I wanted a square root. I only want two factors. We don't have two factors that can be negative and multiply together and give us a negative answer. However, when I have three factors, take your calculator now and I want you to try this and see what answer you get. So type in the 3, press second, then type the root key, then type negative 27, and then press equals. What answer do you get? That's right, you get negative 3 here. Take a look at that. Negative 3 times negative 3. That gives me negative times a negative, positive 9 times negative 3. Negative times a negative times a negative, that gives me a negative answer. So when I have an odd numbered root on the outside of my radical sign, I can have a negative on the inside. If the root is an even numbered, like square root, cannot do it. Cannot do it. But if it's an odd number out here, yes, we can. All right, lastly, let's take a look here. Cube root of a monomial. Find the cube root of 64x to the 12th. All right, let's see here. Cube root of 64. Let's look at our list up here. What number? If you want to, you can actually type it in the calculator. 64, that is the fourth number in the list. So my cube root of 64, yes, that is 4. Now I need the cubed root of x to the 12th power. Let's see here. What number can I add together 3 times? So I'd have an x with an exponent, x with an exponent, and x with an exponent. What is that exponent that I would be here, here, and here? If I add that up, I'm going to get 12 as an answer. So I need 3 of those. Well, 3 times what is 12? 3 times 4. So yes, I need x to the 4th power. So I need the cubed root of the number and cubed root of my variable. Actually, a quick way, there's a little pattern if you notice it. If you take this number here, what can I do to the 12 and the 3 and get 4 as an answer? That's right, I can actually mentally, the shortcut pattern is you can take this exponent and divide it by this out here, the 3, whatever my root is after, and I'm going to find my exponent in my final answer. Okay, this video's gotten long enough. We're up to 12 minutes. Here is what I want you to do. From page 419, I want you to do numbers 1, 3, 5 through 19, 23 to 28, and turn that in when you're done. You are more than welcome to use your calculator. Let me know whatever I can help you with.